My name is Hao Meng. I am a master student at Beihang University. This video will present our work, 3D interacting hand pose estimation by hand deocclusion and removal. Estimating the 3D hand pose from a monocular RGB image is critical in many real-world applications. Our task is to estimate 3D keypoint localization of interacting hands. Compared with single hand scene, there are occlusion and ambiguity in interacting hand pose estimation. Occlusion means one hand might be occluded by the other hand. Ambiguity means the network might be confused by the similar appearance of two hands. Our approach first does deocclusion to restore pixel values of occluded part of a hand, and then does removal to predict pixel values of background behind the other hand. The full pipeline consists of three stages. Firstly, the HASM segments the complete and visible part for both two hands. Then, the HDRM recovers the RGB values of the occluded hand and the background behind the distracting hand at the same time. Finally, the SHDE predicts the 3D pose of each hand separately. As for HASM, we simply adapt the off-the-shelf instance segmentation model. That is, SegFormer. HASM predicts four kinds of segmentation masks, namely the right-hand model mask (MRA), the right-hand visible mask (MRV), the left-hand model mask (MLA), and the left-hand visible mask (MLV). We use the binary cross entropy losses to supervise the network. Given the predicted masks, we locate and crop the image patch centered at each hand. Then, for every cropped image, the HDRM would do deocclusion and removal simultaneously. For clarity, in the following sections, we will focus on the right hand only. We use MD to denote the region where the target hand is occluded by the other hand, and MR to denote the region where the distracting hand occupies. ID and RR are the original image RS erased by the mask MD and MR respectively. They can inform the HDRNet where to focus and how to implement these two regions. Finally, ID, MRV, IR, and MBV are concatenated together as an input. As for the model of HDRM, we enhance the popular partial convolutions with few transformer blocks. Finally, the HDRNet outputs a recovered image I/O. We also employ an image discriminator D to enhance the image recovery quality through adversarial training. The loss function of HDRNet is as follows. LPREC denotes the perceptual loss, and L* denotes the star loss. We choose the datanet of minimal hand as our baseline SHPE for its simplicity and good performance. As there exists no dataset that targets at a model segmentation and appearance content recovery of interactive hands, we synthetically generated the first large-scale model interhand dataset, namely AIH dataset. It is based on the well-known interhand 2.6M dataset. In total, AIH dataset consists of about 3 million images. AIH scene is generated by simple 2D image level copy and paste. That is, copy the left single hand image and paste it on the right single hand image. AIH render is obtained by rendering the textured interacting hand mesh to the image plane. Our approach achieved state-of-the-art performance on in-hand 2.6M and Tizonas dataset. Many experiments have further proved the effect of HDR framework. By the way, we also analyze the time cost of our whole pipeline. The time cost of HDRM is only a small proportion of the total time cost. From qualitative results, we could see that HDR recovers the appearance in the occluded region and removes the distractor in challenging hand-hand occlusion cases. Thanks for listening.